Hello sir, I'm Hitani, 4B7 AC Department Section B. Today my topic is nickel cadmium cell. The first nickel cadmium battery was created by Valdemar Jubner of Sweden in 1899. At that time, the only direct competitor was the lead acid battery, which was less physically and chemically robust. With minor improvements to the first prototypes, energy density rapidly increased to about half of the primary batteries and significantly greater than lead acid batteries. So, the first nickel battery was created by Valdemar Jubner of Sweden in 1899. At that time, there was only lead acid battery, which is to compete with nickel cadmium battery, which is very less and chemically, which is physically and chemically less robust. With minor improvements, the first prototypes energy density rapidly increased to about half of that of the primary batteries and significantly greater than lead acid batteries. Contents: a fully charged nickel cadmium cell contains a nickel oxide or hydroxide as positive electrode plate, a cadmium negative electrode plate, a separator, and an alkaline electrolyte. So the fully charged nickel cadmium battery or cell contains a nickel 3 oxide or hydroxide as the positive electrode plate. That means the positive electrode plate will be nickel oxide or nickel hydroxide. A negative electrode plate will be a cadmium, and there will be a separator and an alkaline electrolyte. Here the electrolyte is potassium hydroxide. Nickel cadmium battery usually have a metal case with sealing plate equipped with a self-sealing safety valve. The positive and negative electrode plates, isolated from each other by the separator, are rolled in a spiral shape inside the case. This is known as the jelly roll design and allows a nickel cadmium cell to deliver a much higher maximum current than the equivalent size alkaline cells. Alkaline cell have a bobbin construction where the cell casing is filled with electrolyte and contains a graphite rod which acts as a positive electrode. Nickel cadmium batteries usually have a metal case with sealing plate equipped with a self-safety valve. The positive and negative electrode plates will be isolated from each other by the separator. These are rolled in a spiral shape inside the case. This roll is known as the jelly roll design and allows nickel cadmium cell to deliver a much higher maximum current than the equivalent size alkaline cell. Alkaline cells have bobbin construction where the cell casing is filled with the electrolyte and contains a graphite rod which acts as a positive electrode. As a relatively small area of the electrode is in contact with the electrolyte as opposite to the jelly roll design, the internal resistance for an equivalent sized alkaline cell is higher, which limits the maximum current that can be delivered. So, as a relatively small area of electrode is in contact with the electrolyte, the internal resistance for an equivalent sized alkaline cell is higher, which limits the maximum current that can be delivered. The chemical reactions at cadmium electrode during discharge are cadmium plus 2 OH minus gives cadmium OH taken twice plus 2 electrons. Here first cadmium will react with OH minus and it will give cadmium hydroxide plus 2 electrons. The reaction at the nickel oxide electrode are 2 NiOOH plus 2 H2O plus 2 electrons gives 2 NiOH taken twice plus 2 OH minus. Here NiOH OH will react with water and 2 electrons and gives nickel hydroxide plus OH minus. The net reaction during the discharge will be 2 NiOH plus cadmium plus 2 H2O gives 2 NiOH taken twice plus cadmium plus cadmium OH taken twice. So the first reaction will be at positive electrode and the negative electrode, and the last reaction will be at the during the discharge. During recharge, the reactions go from the right to left. The alkaline electrode, commonly KOH, that is potassium hydroxide, is not consumed in this reaction, and therefore its specific gravity, unlike in lead acid batteries, it is not a guide to its state of charge. When Jugner built the first nickel cadmium batteries, he used nickel oxide in the positive electrode and the iron and cadmium materials in the negative. It was not until later that pure cadmium metal and nickel hydroxide were used. About 1960, the chemical reaction was not completely understood. There were several speculations as to the reaction products. The debate was finally resolved by infrared spectroscopy, which revealed the cadmium hydroxide and nickel hydroxide. So during recharge, the reactions go from left to right. The alkaline electrolyte is not consumed in this reaction, and therefore its specific gravity, unlike on lead acid batteries, is not a guide to its state of charge. When Jugner built the first nickel cadmium batteries, he used nickel oxide in the positive electrode and iron and cadmium materials in the negative electrode. It was not until that the pure cadmium metal and nickel hydroxide were used. Until about 1960, the chemical reaction was not completely understood. There were several speculations to the reaction products. The debate was finally resolved by infrared spectroscopy, which revealed the cadmium hydroxide and nickel hydroxide. Another historically important variation on basic nickel cadmium cell is the addition of lithium hydroxide to the potassium hydroxide electrolyte. This was believed to prolong the service life by making the cell more resistant to electrical abuse. The nickel cadmium battery in its modern form is extremely resistant to electrical abuse anyway, so this practice has been discontinued. Another historically important variation on the basic nickel cadmium cell is the addition of lithium hydroxide. So the lithium hydroxide is added to the original potassium hydroxide electrolyte. So it was believed that if we add lithium hydroxide to the potassium hydroxide electrolyte, the service of the cell will be increased, and it is believed that the cell is resistant to the more electrical abuse. So the nickel cadmium batteries in its modern form is extremely resistant to electrical abuse anyway. So anyway, even if we add lithium hydroxide or without lithium hydroxide, if we only use potassium hydroxide also, the nickel cadmium battery was very extremely resistant to the electrical abuse. So this practice was discontinued. Let's see about charging. Nickel cadmium batteries can be charged at several different rates depending on how the cell was manufactured. The charge rate is measured based upon the percentage of amp-hour capacity. The battery is fed as a steady current over the duration of the charge. Regardless of the charge speed, more energy must be supplied to the battery than its causal capacity to account for energy lost during charging, with faster charges being more efficient. So the nickel cadmium batteries can be charged at several different rates depending on how the cell was manufactured. So the charging capacity will be dependent upon the manufacturer itself, the manufacturing model itself. The charge rate is measured based on the percentage of amp-hour capacity. The battery is fed as a steady current over the duration of the charge. Regardless of the charge speed, more energy must be supplied to the battery than its actual capacity. To account for energy loss during charging, with fast charges being more efficient. For example, an overnight charge might consist of supplying a current equal to 1/10 of ampere hour rating, C by 10 for 14 to 16 hours. That is, 100 mAh battery takes 10 milliamperes for 14 hours, a total of 140 milliamperes per hour to charge at this rate. At the rapid charge rate done at 100% of the rated capacity of the battery holds roughly 80% of the charge. So a 100 milliamperes hour battery takes 125 milliampere hours to charge, that is approximately 1 hour and 15 minutes. Some specialized batteries can be charged as it is a little some special batteries can be charged in as little as 10 to 15 minutes as at a 4C or 6C charge rate, but this is very uncommon. It also greatly increases the risk of cells overheating and venting due to the internal overpressure condition. The cell's rate of temperature rise is governed by its internal resistance and the square of the charging rate. At 4C rate, the amount of heat generated in the cell is 16 times higher than the heat at 1C rate. So this is an example of this is a nickel cadmium battery. We can see here the company is Nitro Power. Applications. We use nickel cadmium cells in various uses in our daily world. Sealed nickel cadmium cells may be used individually or assembled into battery packs containing 2 or more cells. Small cells are used for portable electronics and toys such as solar garden lights. Often used cells manufactured in same sizes as primary cells. So these will be used in toys and portable electronics. So when nickel cadmium batteries are substituted for primary cells, the lower terminal voltage and smaller ampere hour capacity may reduce performance as compared to the primary cells. Miniature button cells, that is will use these in watches, etc. These are also nickel cadmium cells. Will be used in photographic equipment, handheld lamps like flashlight or torch, computer memory, standby, toys and noveltics. Especially nickel cadmium batteries are used in cordless and wireless telephones, emergency lighting and other applications with a relatively low internal resistance. They can supply high surge currents. This makes them favorable choice for remote controlled electrical model airplanes, boats and cars, as well as cordless power tools and camera flash units. So this is all about nickel cadmium cells. Thank you.